Hi everyone, this is Aegis, a software solution I built to help national agencies monitor the outbreak of diseases in a country. And it also has a crucial machine learning model that could basically help us to forecast the progression of this disease with time under different conditions. For example, this is the status quo in case where a max is being the use of Max is being implemented in a country or whenever there's a national lockdown and in case where there is no intervention at all. So this is a separate forecasting model I built and embedded into this solution. We also have a map view that would basically show the situation of the outbreak in every single state. For example, we can take a look at Niger State and then we can see the situation so far, the amount of population in that state, the entire number of cases that has been discovered since the outbreak started in this particular state, and then we can also check for the forecast for that particular state under the different conditions. My name is Abdulsalam Aderoju. I basically want to give a walkthrough of how I took this entire solution from development to production. That means being deployed on Azure, which is the cloud service I use in this case. This is not something I do often, but then I'm trying to delve deeper into DevOps, and I just chose this project I've worked on as my starting point. I want to keep this video as short as possible, so I'm going to be diving straight into the architecture I designed to basically show how this solution was deployed on Azure, the services in Azure being used, and how I had set up observability to help track metrics, logs, and traces within our application. So as you can see, there are three major boxes. We have the CI/CD pipeline box, then we have the one for production that basically houses the front end, the back end, and the database, which are like the three different layers of application. And then the observability, how I was able to, track trace to put traces in place, logs, and also metrics. And how I was able to come up with an action group that could basically trigger an alert in case certain threshold we set for application are being exceeded. So for the CI/CD pipeline, it typically helps us to automate the process of deployment in case there is any change in our code base. For example, whenever we make a change to the front end code in this application and that change is being pushed to GitHub, automatically the front end CI/CD pipeline automatically pushes um, that changes, or basically it reflects or it deploys the entire front end with that change being implemented in a static web app here. However, for the case of the back end, it's a little bit, it's not as straightforward as that. So in the case of the backend, whenever a change is being made in the backend code base and it is being pushed to GitHub, so our backend pipeline tries to automate the deployment of the entire backend with that change being effected, but then it first makes an image out of our code base because we are deploying this as a container, and then it pushes that image to Azure Container Registry, and then our container app, which houses the backend service, is going to automatically pull the image from this ACR and then spins the image up as a container in the container app. So that's what the CI/CD pipeline is all about. In case then it just to automatically redeploy our application in case or in a situation where any change is being made in our code base. So from now on, if I make any change in the code base of Aegis, it get automatically deployed to whether backend or front end. So this basically shows how this works in production. A user interacts with a front end which is deployed as a static web app on Azure, and they send in requests from this front end, and that makes API calls to the backend, which is deployed as a container app on Azure. So we basically containerized this our backend service, then deployed it on Azure Container App, which is a managed service in Azure. It's a serverless service and makes it very, very easy for me to handle this because I wouldn't have to um, be dealing with a virtual machine, setting up the OS, managing the entire infrastructure. So this basically works very fine and makes the work very much easier. So that's why I made use of a container app here. And then we make use of Azure database for PostgreSQL to help host our database. So whenever a user sends in a request, API call is being made, and then the API sends a query to the database and then sends back a response to the user. So that's basically what's happening here. And as this is running, we already set up observability to help track the metrics, the traces, and also we can also take a look at the logs in this application. So the logs basically makes it easier for us to pinpoint the specific issue happening within our application, and then the traces would help us show the journey of every single request being made, so we can see certain requests that are taking time to get a response, and or it just makes it easier for us to monitor the time it takes for every request that we made. So we have metrics allowed we set up for the CPU usage, memory usage, and DB connection. We also have one for availability that tells us how available our application is whenever a user tries to make a request just make use of our application. And then an action group is being set, which basically is being triggered whenever an alert fires on. The alert basically monitors the different metrics we've set, and whenever um, a metrics exceed a set hold we already set, a threshold we already set, an alert is being triggered, and then the action group would take effect. For this project, I basically set a email notification. So, for example, if a DB connection exceeds an amount we already want to undo, it sends an email to me to tell me that okay, we already exceeded the number of DB connection we are hoping to get for this project. So in some cases, that tells us, oh, do we need to scale up or we need to scale down, or do we need to allow more CPU usage, or just help us make those kind of decisions that would make sure our app keeps running at every single point in time and runs as fast as we want it to at every single point in time, so that our users don't experience any sort of downtime. So that's everything with the entire architecture. And now I want us to take a good look at the code and how we're able to come up with this entire thing. So quickly, let's take a look at the um, how we made use of Terraform to provision the different resources we made use of in Azure. As we can see from here, we made use of Terraform, and then Azure is our cloud provider, and we made use of this um, Terraform file to create different resources within Azure from our local machine using code. So basically, we are setting up different resources using code. Here is our PostgreSQL server, and here we have the container app which houses our backend service. We have the static web app which hosts the front end service, and a whole lot of other resources we need, especially for observability as well. The action group, everything are written in code. And the reason why Terraform is super important, especially for this kind of for anything DevOps basically, is that we can basically provision um, the entire resource within 3 5 minutes, and then we can destroy it at the same time just right from using code and just running this file here. So basically we can take a look at this and how it works. So let's go into this folder. and then we can basically try to do Terraform plan. So this is going to, if at all there were any changes made in this main.tf file that provisions our entire architecture in our entire infrastructure in Azure, it basically tells us from this plan, and then if there is at all, we can now apply that plan and it automatically creates the additional resource we want in our infrastructure. Or if at all want to destroy the entire infrastructure, we can just automatically do Terraform destroy, and then it deletes the entire infrastructure at once. But the good thing with Terraform is that whether even after destroying it, we don't need to go through a very lengthy process to recreate that. We can just do Terraform apply again, and then it provisions the entire infrastructure once again. So that's the good part of Terraform. This entire thing is loading. So while it's loading, I'm going to try to trigger a CI/CD pipeline by making some changes in our backend. Let me just make a very tiny change in our backend. Yeah. So let's say all API routers. So I can save this. That means I've made a change in my backend code base, and then I'm going to be pushing that to GitHub to show us that we are going to automatically deploy this thing without having to manually go through the entire process of deployment I initially went through when setting up this project to production. So the result of our Terraform plan is out, and basically we can see the current infrastructure on Azure matches the configuration that has been set in Terraform.state. So we don't need to make any sort of changes anymore, and we have everything we want provided in Azure. We're going to show the Azure portal, but first let me push this backend code and see what we have. So new changes have been made to the code base basically in our backend folder, right? So we're going to push these new changes to get up so that I can trigger our pipeline to redeploy the entire backend service on Azure Container Apps. So basically we have let's do git add everything. Let's say git commit testing pipeline, and let's do git push onto origin main. So we're pushing to our main branch because that's basically where we need to push it to in order to trigger the pipeline. So we already have that. Now let's go back to GitHub and see what we have. So right, already doing this, testing the pipeline. This entire thing is loading. So this is the pipeline running. The pipeline was set up using GitHub Actions. So it's basically, it has multiple steps. So you can see set up the job. It logs into Azure using our service principal. Okay, then same thing here. Then logs into ACR, which is where the image being made using our Docker file get pushed to, and that's where our Azure Container App is going to pull that image from. So it's very seamless and very easy to do that because both of them are Azure managed services. And yeah, it's building and pushing the Docker image to ACR, and then deploying that image to container apps. So that's like the last process or the last step being implemented here. So once that is done, we are going to have our entire backend service being redeployed just due to the change we made in the code base. So from now on, any changes made in our Aegis application, whether I need to add more features, whether I need to debug certain things, in cases wherever we're having downtime or certain requests are failing or I need to update anything. So this is now the process that it just follows. Yeah, so the new changes get automatically deployed, and that's like the good part of the the CI/CD pipeline being put in place. So this is the entire thing. Once it is done, we're going to see that the new changes have been made. But because it's not significant, it's just adding extra comments to our code base. So we might not see that in real time. But in case it was like adding a new feature or adding something very very interesting, very significant in our code base, we are going to see that get affected in real time on the AD's application. So this is done. As we can see, the get marked as done with this green check mark here. So it shows that the entire thing has been redeployed. The entire backend service has been redeployed. So now let's take a look at the observability we set up in order to track the health of our application and how things are going. We can now see the logs, the traces, and the metrics in real time, the action group, the alerts we set, and every single thing. So let's go to monitor real quick. This is monitor here. So why is this not here? Why is this not working? So this is monitor. But that is wrong. Okay, that's monitor. And here, for example, you want to see the traces. Traces basically helps us track the journey of a request in the application. Let's do this. So this is the app insights being set up. So we're able to set this up right from Terraform, and then we can view it live within the Azure portal to show everything that we need to see. So now we have, it can show us, we are able to see the number of field requests. We're able to see the server response almost pretty much for every single request made. You can see the amount of requests that have been made, about 5,400 requests have been made so far. And then we can see if how available our software application has been. So far so good. It's been 100% available, meaning if a user wants to access this application at any single point in time, it has been available so far since this test has been created. So um, that's that about the traces. That means tracing every single request. So we can see the field request. It basically tells us um, the top three response codes for cases where things failed. This is 401 unauthorized, um, and an error showing the user wasn't authorized to use the application. So this possibly happened in cases where a user was trying to log into the application using a wrong password or wrong email address. It can tell us the particular endpoint throwing errors. So for example, here this failed 7 times. I'm trying to access the user trying to access the coordinator dashboard failed about 2 times, and history failed once. Same with trying to submit a trying to make a submission also failed once. So that's everything with the traces. Now we can see for metrics. So this is it on a larger view. Let's try to see for metrics. Um, what's going on? Why is it not loading? Oh, sorry. So from here we can get to see the logs. So far so good. we would basically run certain queries to help us see specific things, but that's not what I'm going to do here. I'm just going to come right to tables, then log management, and let's see. Let's run for app request. Right. So this is for the last 24 hours. For the last 24 hours is mostly um true success almost at every single point in time. That means the application was really good. In some cases, it shows certain duration. It took some time to load certain things. So in a case whereby we're having issues with maybe our application is having some downtime, we basically come here and see which particular requests are causing those downtime, or just basically pinpointing the issue we are having, and then from here we can see what's going on, and then we can now know how to resolve whatever issue we're experiencing. So we also have metrics. So for metrics, we can basically um, track the different things we already set. For example, let's see for the backend, we already set some metrics for the backend. For example, we can see our CPU usage. So the CPU usage has been pretty consistent. I think this is at the point where we made certain requests, or maybe we try to use the forecasting model. That's where we usually experience those hike in CPU usage, because the forecasting model would definitely consume um, some CPU usage, let's just put it that way. So that's everything with this. We can basically track everything we need to track throughout the course regarding this application. We can add new metrics, we can add new action groups. We already set some action groups. The alert is also there. We have about 4 alerts being set at the moment. We can add more, and just get to add more things that will make us have a complete control of the application we've built. So these are the usage of the usage nano cross for CPU restart count, number of time application starts, restarts, and then we have the working service by the active connections to the DB. So whenever they exceed this particular threshold being set, then we get an alert, and the alert basically is all, in all cases, is to basically, the action group basically is to send an email to me informing me that, oh, something is going on, or we have exceeded the certain threshold we set for whatever we currently have. So this is the complete implementation of the project I worked on in DevOps. Next up, I'm going to be working on something very much interesting, where we're going to be dealing with microservices, deploying these microservices, and we're going to be using Kubernetes, because we are indeed going to be managing um, we're going to be managing multiple containers. And so I think that's all. Bye. Thank you for watching. If you watched up to this point, but if you didn't, I don't know, you're not going to be hearing me say so. But if you watch up to this point, I think I'm going to be doing more of this. It's going to get better with time, basically. And and I'm going to just pretty much do a walkthrough of every single DevOps project I'm going to be working on. And I just hope we try to learn more routines, or we enjoy, or you enjoy me demoing whatever thing I've done. So thank you, and bye for following me up to this point.